In this video, we're going to look at how to add integers when they have the same sign. And I want you to keep in mind an integer is any number that you would find on the number line. So those are all our positive whole numbers, their opposites, and of course 0. So today we're going to use some manipulatives to help us figure out the answers to our questions. So anytime we see a red counter, we're going to treat that as a negative number. And anytime we see a yellow counter, we're going to treat that as a positive number. So as we work through these examples, I want you guys to try to think of what rule we could follow so that we know how to answer the question anytime two integers are added that have the same sign. And when I say same sign, all I mean is I'm either adding two positive numbers together or two negative numbers together. So here's our first example, and I'm going to start off over here with what is a very, very simple problem, just so we could see how to model it using integer chips. Now keep in mind my yellow chips are positive, my red chips are negative. So if I wanted to model a positive 3 being added to a positive 2, I'm going to use 3 yellow chips for positive 3 and 2 yellow chips for positive 2. Well, if I have 3 and I add 2 more to it, that's going to give me 5. And you guys already knew the answer to that. Okay, now I notice that all my chips are yellow, which means these are all positive. My answer is positive. When I jump over on this side, I'm adding a negative 3 and a negative 2. So negative 3 would be modeled with 3 red chips, and negative 2 would be modeled with 2 red chips. I'm going to add up how many red chips I have, and I see again that I have 5. But this time, each of those chips is a negative value, so I actually have a negative 5. So when all my chips are red, or all my chips are negative, my answer is also negative. Let's try another one. Again, the first side is very simple. 1 plus 4. Well, whoopsies, let me fix this real quick. I would model a 1 with a yellow chip for positive 1, and a 4 with 4 yellow chips for positive 4. And I'm going to count up how many chips I have, and I see that I have 5 chips. Ooh, 5 is my lucky number. And each of these chips are positive, so my 5 will also be positive. On the other side here, we're adding a negative 1, so that's a red chip, and a negative 4. That's also going to be red chips. So 1, 2, 3, 4. If I count them all up, I see that I have 5 red chips, so I know my answer is 5. But my answer is actually going to be a negative 5 because each of these chips are red or has a negative value. Okay. And the last one we're going to do, again, 2 plus 5. I'm adding all positive values. I'm using all yellow chips. So I have 2 here. So 1, 2. I'm adding a 5 to that. So 1, 2, 3, 4, 5. I see that all together I have 7 chips, and these are all positive numbers, so my answer is positive 7. On the other side, I'm adding 2 negative numbers together, so a negative 2 is going to be 2 red chips, and a negative 5 is going to be 5 red chips. Again, I count up how many chips I have. So in this case, I have 7 chips. But this time, all of those chips are red or negative values. so my answer is a -7. We could also do this on a number line instead of using number chips. So if I look at example A here, we're going to do A in purple. -2 plus -4. So I'm going to start off with that first number in the equation, and I'm going to find that on the number line. So -2 is right here. And I'm going to put a little dot. And when I add a negative number, I'm actually moving further away from 0. I'm going to move to the left. I'm getting smaller. So I have to go 4 times to the left. So 1, 2, whoa, that wasn't supposed to happen. Let me fix that. 1, 2, 3, 4. And I'm going to draw my arrow so that I know that I moved to the left. And the number that I left off on here is -6. So that tells me a -2 plus a -4 is a -6. And if I think back to using integer chips on that, if I had done -2 and -4, I would have 6 red chips, which would be a -6, so that makes sense. And let's try example C here. We'll do this one in green. So I'm going to erase all this actually, so we have some space. So in example C, I have a -3, so I'm going to go to -3 on my number line. And I'm adding a -2, and again, a negative number will always move to the left. So I'm going to go 2 places to the left. I'll draw my arrow so I know which direction I went. And I'm now looking to see where I left off on my number line. I left off at -5. And again, if I think of integer chips, I would have 3 red chips and 2 red chips, which would give me 5 red chips, which means it would be -5. So we're going to come back to the question we started off with. What rule can we write that can be followed anytime we add 2 integers with the same sign? And if I look back at all of my examples, when I started off with both positive numbers, I ended with a positive number. When I started off with both negative numbers, I ended up with a negative number. And you'll see through every single example that is true. So that is going to be our rule. Our rule will say add the integers and keep their sign. So at this point, I'd like you to pause the video, try these 4 questions, and then go ahead and press play and you can check your own work. Welcome back. So in the first one we have 3 plus 9, which I'm sure was very simple for you guys, and 3 and 9 are both positive, so we end up with a positive 12. Number 2, -10 plus -5, I'm adding 2 negative numbers, my answer is -15. Number 3, -2 plus -14, again I'm adding 2 negative numbers, my answer is also negative, so it would be -16. And the last one there, -1 plus -9, is -10. Again, because I added 2 negative numbers together, I get a negative answer. If you have any questions, please jot them down and let me know.